Chemical bonding. Now, in this topic, I'll discuss that what is the need of a chemical bond? Why do elements combine with each other? Okay, so the need of chemical bonding is to find out why do elements combine with each other. Basically, what is the reason behind that? Why do we have 118 elements, but they combine with each other, right, in a specific ratio? So, what is that? Why they are combining with each other? Why sodium combines with chlorine atom? Why hydrogen combines with oxygen atom? Right, in H2O molecule, why two hydrogen atoms combine with one oxygen atom? So all these things we will discuss in under the topic chemical bonding. So first of all, we'll discuss what is a chemical bond. So a chemical bond is a binding force which is holding a group of atoms together to form a stable molecule, right? That is called a chemical bond. Right, now how do elements basically complete their octet, or how do elements basically acquire stability? So they acquire stability either by completing their duplet, having two electrons in their valence shell, right, as in case of hydrogen helium, or by acquiring 8 electrons in their valence shell, which is known as to complete their octet. So either they complete their duplet or they complete their octet. That is called, basically that's the reason for elements to attain, basically do chemical bonding. Right, now the main task is that how it is possible, how an element can complete its octet or duplet, right? How an element acquire the stability, or how an element acquire the stable configuration of its nearest noble gas. Like for example, sodium is an element whose atomic number is 11. If we write the configuration, electronic configuration will be 281. Now, if you see sodium, it is having K shell Lm. In K shell, it is having 2 electrons, L shell is having 8 electrons, and M shell is having only 1 electron. Now, how this element can acquire stability? Sodium atom can acquire stability. It is easy for sodium to lose this electron. So when sodium will lose this electron, so loss of electron can be represented by this. So sodium will change into Na plus, right? Or we can say sodium configuration was 281, and when it converted into sodium, it will have 28. So you can see that after losing the valence electrons, sodium is converted into sodium ion. Okay, positively charged ion, because there is a loss of, whenever there is a loss of electron, you will acquire, atom will acquire a positive charge. If there is a loss of 1 electron, it will acquire a +1 charge. If there is a loss of 2 electron, 2 plus charge, 3 electron, 3 plus charge, like that. Now, if you see carefully that sodium's configuration is 281, whereas sodium ion is 28, right? So you can say this is how, that is how sodium is attaining the stable configuration or completing its octet. Right, so that is the reason that elements basically lose or gain electrons. Right, elements lose or gain electron to basically complete their octet or duplet. Now the question is that is it possible only by loss or gain of electron? Right, to explain this topic, I'll tell you that there are two ways in which elements can basically acquire stability. There are two modes, two ways, right? What are the two types of chemical bonding? Chemical bonding. In chemical bonding, we will say there are two ways in which the elements can acquire stability. The first way is transfer of electron, transfer of electrons. Okay, so when there is a transfer of electron, it results in the formation of your ions, and this type of bonding is known as electrovalent bonding, electrovalent or ionic bonding. The second mode is support transfer of electron by losing or by gaining electron. We are not getting the octet configuration completed, or our target is not fulfilling. So in such case, we have another mode that is known as sharing of electron. Okay, sharing of electrons. So when we basically follow the upper mode, this mode, to complete the octet, that is called electrovalent or ionic bonding. And when we do the sharing mode, right, when we complete the octet by sharing of electrons, this is known as your covalent bonding. Right, this phenomena is known as covalent bonding, and the bond formed by such sharing of electrons are called covalent bond. Right, so we'll discuss one by one both type of bonding in detail. So first let me explain you covalent bonding, sorry, electrovalent bonding. First we'll do electrovalent bonding. Okay, so what is electrovalent bonding? Electrovalent, the type of attractive force, which is the strong electrostatic force of attraction, which is holding the two oppositely charged ions together, is known as your electrovalent bond, and this phenomena is known as electrovalent bonding. Okay, now let me take the example of sodium chloride to explain you this. Let me take the example of sodium chloride to explain you this, right? So now I'll write the Louis dot structure for sodium. Now how to write the Louis dot structure, that I will discuss in my another video. Okay, so when we write the Louis dot structure, we write the symbol of the element, and we show you or we show around it only the valence electron. So you know atomic number of sodium is 11, so 281, right? So here the nucleus and the inner shells are represented by the symbol of the element, and the valence electron we will show in the form of an electron around the sodium atom. Similarly, you will write chlorine atom. So chlorine is atomic number is 17. So 287 is its electronic configuration. So how will you show the valence electrons around the chlorine atom? Total how many electrons do we have? 7 electrons. So in Louis dot structure, what we do? We write the electrons, the symbol of the element and the electrons which are present in its valence shell around the that symbol, right? So sodium's Louis dot structure is this, chlorine's Louis dot structure is this. So if you see now, sodium basically will acquire the its configuration or octet configuration by losing this electron, and chlorine needs one more electron to complete its octet. You can see clearly here you have one electron which it can donate. So when it will donate, right, it will become Na plus, and its configuration will be 28. If you see chlorine atom, it is 287. So if it will gain one electron in its valence shell, it will become 288. So now we'll show you the transfer. So right, how will you show the Louis dot structure for the formation of sodium chloride? So from Na, one electron will be transferred to chlorine atom, right? When one electron will be transferred to chlorine, how will you write now? Na will change into Na plus, that is 2, 8 stable, and chlorine will now have 2, 4, 6, and this electron is the 8th electron which came from sodium atom. Now it will also become 288. So you can see that after the gain of electron, because here loss of electron is happening, right? That is why sodium acquire a positive charge, it changed into an anion. Okay, whereas chlorine changed into negatively charged ion, sorry, sodium gain electron, sodium gains electron, and it is converted into a cation, positively charged ion, cation, and chlorine gains one electron and it is converted into your anion, right? Now, what type of force will exist between these two oppositely charged ions? So there are two oppositely charged ions. One is positively charged, one is negatively charged, right? So the two oppositely charged ions will be held together by some type of force of attraction will exist between them, which I am trying to represent it, but there is no specific bond which we a presentation to show you. It's a type of attraction which is holding these two oppositely charged ions together. So we'll say in that way these two ions will always remain together and it will form or it will give rise to sodium chloride. Correct? So this is the formation of your sodium chloride, and this is an example of an electrovalent compound or ion. The compound or the compound which is formed by the transfer of electron is known as ionic compound or known as electrovalent compound. Right? So now here I am also explaining your term called electrovalency. Electrovalency. Now what is electrovalency? Electrovalency means during the formation of such ions, the number of electrons which are donated by the cation, donated by a metal, you know, sodium is a metal also, okay, and it's a non-metal. Okay, you can say during the formation of an electrovalent compound, the number of electrons which are donated by one atom, that is called its electrovalency, or the number of electrons gained by an atom, that is called its electrovalency. So if you see in this particular example, in case of NaCl, Na is losing one electron, so its electrovalency is +1, and right, for cations you will say +1 electrovalency. And if I am asking you what is the electrovalency of your chlorine atom, so chlorine is gaining one electron, so its electrovalency will be 1 minus. Okay, it will be 1 minus, plus 1 or 1 plus, anything you can write. Correct. So that is called its electrovalency, the number of electrons which are lost or gained by an atom to acquire stability or during the formation of ionic compound is called its electrovalency. Whenever you write electrovalency, you need to write with the symbol plus or minus. Okay, one more thing here, electrovalent compounds always formed between metal and non-metal. Now what are metals? Those elements, how will you figure out what are metals? Those elements which will have 1, 2 or 3 electrons in their valence shell will always donate electron and they will categorize as metal. How will you recognize? If I am giving you an element X, okay, an element X with its atomic number, like let's say I am giving you atomic number 19. Okay, so what you will do, first of all, always distribute the electrons. So you know electronic configuration of 19 will be 2881, right? So you can see how many electrons are in there in the valence shell. So if you have 1, 2 or 3 electrons in the valence shell, then that element will be considered as a metal and it will always have a tendency to lose electron to form cations, right? And if the element, right, another element, suppose you have an element Y, an element which will always have like 4, 5, 6 and 7 electron in the valence shell, they will be considered as non-metal, right? So suppose an element, I am giving you atomic number 15. So how will you distribute the electron? You will say 2, 8, 5. So you can say 5 electrons are there in the valence shell. So 5 electrons means it will come under this category. It will be a non-metal. So how to recognize a non-metal? Non-metals are those elements which will have 4, 5, 6 electrons in their valence shell are called non-metals. And non-metals will always gain electrons. And if they are gaining electron, obviously they will convert into the respective anions, right? So whatever electrons they are gaining, that much negative charge they will acquire. So this is the formation. I explained you electrovalent bonding by taking the example of NaCl. In my next video, I will discuss few more examples of electrovalent bonding.